everyone, how are we doing? Chapter 10 quiz? Yeah, sure. Which one's the chapter 10 quiz on my Pearson? AJ, you're here first. You get to pick first. And we need to do that, the Canvas content we were asked during class today. Remind me to do the Canvas content here in a little bit. AJ wants chapter 10 quiz. Which problem are you working on? We can look at some chapter 10 quiz. Let's go here. Which problem are you working on chapter 10 quiz? I've got chapter 10 loaded up. So whichever problem you want to do. Yeah. Did you the question was, so Caroline via email, what you want to do. Let me show you Caroline first right here. I'm going to jump to Caroline's thing. And you know what, Caroline? I am going to kind of show how to do it here. Let me go, I think I have the diabetes one open. Let me go grab that data set. Here we go. Okay. Okay, so Caroline, we're doing Caroline's first, then we'll do AJ's, then we'll go Layla's. So here we go. And thank you, Caroline. I just got my coffee. So, so Caroline, here's what I would do. You were on this step right here, pivot charts. I'm going to drop right here. And so I'm going to zoom in so you can see what I'm doing. So you can see what I'm entering into the bottom fields down here. So you had, it was blood pressure, right? So we're going to take blood pressure. That's all right. Yeah, we can hop around. I replied to Caroline, so that's why I'm going to do this one real quick. And then I would go right here, and I'm going to zoom in so you can see what's going on. And thank you, everyone, for swinging by. We're going to do as many questions as we can. We're going to go right here and change this, go on the value field setting, so you can check this out later, too. No worries, AJ. No worries, AJ. AJ, we got this right here. And we're going to go, oh, you can't see it now. I'm on a coffee high right now. Does this all make sense what I'm doing right here, Caroline? I'm changing this to average right here. I'm changing this to average. So now you'll notice this is the average blood pressure. Now, I would delete the decimals right here. You want to go to home and delete decimals. And I'd say that's a pretty good display of it. And now all we're going to do, and this is what I was mentioning via email, is we're going to take something like age group right here and pregnant status, or no, go diabetes. This is the one I helped create for another student. I added in that variable right there because they asked if we could. We did it during class. I can send that to other people if they want to, but they wanted whether or not someone was pregnant, so I added that onto there. So now we have the different groups right here, whether they're older, younger, whether they have diabetes or not, and their blood pressure. So all we're going to do now is go here and go to pivot chart, and we're good to go. Is this making more sense right here? Is that making more sense, Caroline? Oh, which part? I'll show you what this looks like again here. This is what I have. Oh, how to delete decimals. To delete decimals, you need to highlight the cells you want. So you can hold shift and click another cell. So I'm highlighting the cells I want. And then I'm going to go here to the delete decimals button, which it's going to be this one right here. This is increase decimals. This is delete decimals. Does that make sense? How to interpret? Yeah, let's talk about that really briefly right here. When you interpret this one, you need to have the table on it to interpret it. So I'm not going to fill in everything right here, but let's go to the design. Let's go to quick layout. And this right here, I'm going to zoom out. I'm going to put it over here, and then I'm going to zoom back in on it. Oops. And this is a little bit of project talk right here. I know AJ was also wondering about the project. This right now does not have an axis title. So I'm going to add in a chart element and go to axis title and put that right there. So, I mean, what do you notice right here? Who had the highest blood pressure? People who are what, who have what, had the highest blood pressure. This is the average blood pressure. Yours doesn't look right. Make sure it has the following information. Make sure you have average blood pressure, and I've got here age group and diabetes. So make sure this is average blood pressure down here. So this is average blood pressure, age group up here in this one, and then diabetes right here. And then it should look like, hopefully it does. Make sure this is average blood pressure, though. You might currently have, I need to make that so I can click it without clicking over there. You might have something like this right here. So if you have this, you probably have some, and you want to change that to the average. So does that make sense right there? Is it looking more like it right now? Is this looking good? And then Layla, mine was GPA generated significant other. Female GPA has no effect. That might be what you see, Layla. That might be what you see. Can you send me an email of what yours looks like real quick? Reply to me an email and I'll answer Layla right here, and then we'll go to AJ's question. Just reply in your email, take a screenshot of it, Caroline, and then I'll look at it. You can also tell me, Brian, show it or not, but we'll mention that one real quick right here. But just take a screenshot of it and send it via email. Just reply to the email you sent to me, and I think I got the emails over here. So reply in the email to what it looks like. Yeah, I see it right here. Okay. You have age. You have age over here. You don't have age group. You have age over here in this one. Remove age and change that to age group, and I think that'll fix it. And then you can just add in the stuff. But you have age. I have age group. I think that's got it. And there we go. So change that over. Did that fix it right there, Caroline? Hey, what's up, Brody? Good to see you here. Good to see you here, Brody. So right here, and I'll show what it is again. In this area, you have age, and I have age group. So yours is looking. You'll confirm. Yours looks more like this right here, and mine just went insane. There. Oh my gosh. You see, it's just totally broken. It's just totally. Oh, you can't even see it. It's in the background. Where is age group? It should be down here at the bottom of it. Do you see age group? There you go. Yeah, awesome. Now, does it look more normal now? Does it look more like an actual graphic? There we go right there. And I'd have to change this around. My fonts are really big right now. But it should start to look more like it. Awesome. Good job. Great work. Hey, you got it. Thank you, Caroline. That's why whenever you get stuck, just email me, ask a question, say, hey, Brian, this doesn't look right. So great work right there. Thank you so much, Caroline, for asking. No, I can see like a lot of times if you get stuck, it's just like, well, it's broken, it doesn't work, and I don't it's I've had it where I'm doing coding especially. How do I add in the titles? Are you on, let me think, you're on a Mac, right? Or are you on a Mac or a PC? I can't tell if that's Mac or PC. Just from the screenshot, I can't tell. Are you on a Mac or are you on a PC? Both of them. Mac, okay. You hate Microsoft. When you click on this right here, you should have the add chart elements. So look up here in the corner and you should have the add chart elements. So when you go right here, you can add like a data table. One of the quickest things to do is to go to the quick layout and choose this one. This one has everything except one axis title. So these options right here, you have to be clicked on it though. You have to be clicked on it to make the design window appear. So look for the design window right here. And then once you're clicked on it, be in the design window. You can choose different layout options, but this is where your titles are going to be. So that should have it right there. Could you make sure my data set is good to you since I found my own? Yeah, of course, Simran, of course. Did you send it to me, Simran? Is it, if you want to send it to me, tell me if you sent it on Discord or email. We're going to go to, it was AJ's question, right? AJ was wondering if I could do did you mention which problem, AJ? He said chapter 10 quiz. Which problem from it? AJ, if you can drop a problem in here for chapter 10 quiz, and then Layla wants some chapter 12. So if you mention which problem you're working on, so feel free to put a problem. You sent it via email. Okay, cool. Let me take a look. I'm going to hop back here to space. So if anyone has a problem they want from one of the chapters, go ahead and put the problem you want. I'm going to take a look at Simran's data set here. I hear a data check. Yep. Ooh, it's a Kaggle data set. Yes, of course. Kaggle's awesome. And they've got some analysis on it too. You're free to look at their, and don't copy their analysis, but they've got a lot of cool stuff. Let me go get this data set. I'll go take a look at it right here. Looks like it's probably good. Okay, I'm opening it up right here. It's pretty good. It's missing. I'll send this back here, Simran. Give me a second. Okay. So, Layla's got one. I'm kind of confused. Chapter 12 mostly. It kept lagging, so I kept having to refresh. I need to go back and watch it. I have to go to work, but can I send you a project? Look up? Yep, send me a project. Yep. In a large school with 34 elementary schools. Yep. Let's do the one next here. Let's go right here. I'm going to take this. I'm going to bring this into Jump. I'm going to send this to you in a moment back, Simran, to make it work for the project. Okay. Ooh, I don't like that they did this. You can see what they did right here. I think there's 2 levels to that. Which one, Simran, do you know which one is male and female? Because they're using binary operators right here. I could look at their data dictionary. It's the wrong one. I don't like that they used the binary. They've got, people got analysis right here, which is really nice. And they got validation and stuff on it. Do we know which one is male and female? Discussion. Yeah, here we go. Someone asked about sex. 0 equals female, they're saying. Okay, there we go. There we go. And then they might actually have a categorical variable here. They're doing their categoricals as, so watch out. I'm gonna send you this back. I don't know what CP is. But if you want to change something into categorical here, because that looks to be categorical, we need to go to nominal. Xe and G looks to be nominal also. I'm not sure. Let's go here, older. We'll say older than 50 is older. Whoops, I deleted that. And I'm going to send this back to you, Simran. I'm just making it more applicable. But you're free. So we'll say older than 50 is older. And these are like younger people. They're kids like me. So here's the younger people. So I'm going to send this back to you, Simran. But that's got it. Is this making sense right here, what I've done with this data? Let me go back and look at everything right here. I decided to use age level and gender as a categorical variable in cholesterol content and fats. Yeah. Here, and you can, whatever you've been doing, if you want to use this right here, they're using, do you see how I quickly changed sex to, you could just change sex right here to a nominal variable. And so sex should be categorical for Jump to analyze it this way. And people are talking about this in the discussion on it. So this is really great. This is a great data set. Let me send it back to you right here. Actually, wait, fasting blood sugar is categorical. Oh, okay, yeah. Be looking through this and ask questions if you have it. But this is an interesting data set. And let's go here for, I'm just going to call it data 8. Okay. I'm going to send this back to you here. If you need any help converting it, but it looks like it has enough categorical and quantitative. I can use resting blood sugar. Yeah, this is a really cool data set. Thank you, Simran, for finding this and looking at it. I'll have to take a bigger look at it. This is totally fine to use. If you have any questions about how your graphs are turning out, let me know, because this is definitely like a different one. I'm sending you back the data set where I just did some configuration on it. Yeah, anytime. And we see here, we got AJ's question first, and then we're going to hop over to Layla's question. So we got here the PTA question, Let's do the PTA question from, here we go. So AJ, let's work on some PTA question right here. Okay. So in a large school system, we've got a PTA that's trying to understand the views of parents. Ooh, we got one of the toughest ones. So, well, it's not that bad actually. Ask the parents, we're going to get to the views of the parents. We're going to ask the views of the parents at the next PTA meeting. So would this be convenience, cluster, stratified, or simple random sample? We're going to ask the views of the parents at the next PTA meeting. Would this be a convenience sample? Would it be a cluster sample, stratified, or simple random sample? Simple random sample is when we give everything a number and then we select those numbers randomly. Stratified is when we put things into strata, acknowledging differences, and then select within the strata randomly. Cluster is when we have things put into random groups and then we take the whole group and do a census on the whole group, random whole groups. And convenience is when we do something really easily, and that's not a good idea. So what would this be right here? A, B, C, or D? We'll have you guys pick out the first one telling us what type of sampling it is, and then I'll talk about the bias that might ensue from it. So what kind of sampling method is this right here? What kind of sampling method? Any ideas? We're going to just ask the parents at the next PTA meeting. Well, this is going to be convenience, and so it's stratified. Good answer right there. Stratified is going to be when we acknowledge a difference. And so if we stratify, we need to say like, okay, we have this group of parents and we have this group of parents. So this one's going to be convenience because this is like easily getting the parents. Like we're going to be like, let's just get the easiest parents to talk to. And so I think they have down here, oh, this is tough. So we're going to ask the parents for their opinions at the next PTA meeting. Undercoverage bias could result since only parents involved with the PTA will be sampled. Undercoverage bias could result since the parents in the sample may not be representative of all parents. I think response bias, no. Stop doing that, my Pearson. I think it's going to be this one. I'm a little scared on this one since they're all at the meeting anyways. Yeah. And yeah. Undercoverage, because we're only going to parents involved with only the PTA meeting. We're going to undercover parents who don't go to the PTA meeting. Pretty sure that's pretty scary right there. Randomly select 50 parents from each elementary school. So be careful right here. We're going to randomly select 50 parents from each elementary school. Let's go back to our notes. So we're going to randomly select parents from each elementary school. And we've got here some notes from today on how to know the difference between cluster and strata. So we're going to randomly select parents from each of the 50. It is doing a simple, we're randomly sampling 50, but from each school. But each school is the what right here. It's specifying schools, exactly. It's specifying schools. So you're on the right track with that, Layla. You're getting it. Since it's specifying schools, which one are we doing? So we're going to take 50 students from each school. So the school is the what now? The school is the what? So look at the key things right here. List of names. So then here, we can do that one next here. AJ will get it. Yep. So on Canvas Content 8, but mine has 2 questions, so I submitted. I got a 4. I tried doing it on the Firefox. Oh, Ritu, I'll fix that here, Ritu. Thank you for saying that. Let me see what's going on with that. And yeah, we'll see. I might give you more. I'll probably give you more attempts with the issue with that. Well, so is this going to be stratified or cluster? Is this going to be stratified or cluster here? And then we'll look at AJ's one. So with this one right here, we're going to take 50 students from each school. And are the schools a strata or are the schools a cluster? We're going to take 50 students from each school. So are the schools a strata or are the schools a cluster? What are the schools right here in this instance? Are they strata or are they clusters? And look at the differences. We're going to take 50 students from each school. Hint, we're not taking all the students. We're going to take 50 students from each school. So what are we doing? It's going to be the strata. So with it right there, we're going to do stratified because what are we doing by taking 50 students from each school? We are doing what right here? We are acknowledging a difference. If it was a cluster, how many students would we take from each school? If it was a cluster, how many students would we take from a school? If we were doing schools as clusters, we would go to a school and we would sample how many students. Yeah, we'll do that here in a little bit, read too. Yep. We'll be doing that chapter tomorrow. And that's what we are doing right now, Layla. You are correct. We're acknowledging the differences between schools. And if we were to take a cluster of a school, we would take the whole school at once. So here we'll go ahead and answer this one. Then we'll go to AJ's specific question right there. So looking at this right here, this is when the school is treated as strata because we're acknowledging a difference and then we're sampling representatively of each school. And now we're totally fine. This is a good sampling method. This is a random sampling method. Now, wait, here we go. Bias would only occur. Oh, no, that's all right. That's all right. Totally. Here it is. This is like AJ's right here. List the names of all students alphabetically and then contact every 50th student. So what sampling method are we doing when we contact every 50th student? What sampling method are we doing when we contact every 50th student, starting at a random starting point technically? So remember our examples from today where Reese was watching Drake and Josh? We're doing systematic. So every blanked observation from a certain starting point, and these are the rules for systematic. Pick a random starting point, select every kth observation. And this is a good method for sampling right here. This thing's trying to mess with me. So this would be systematic. This is the one, select every 50 student from a random starting point, and bias would only result if we do not follow as described. Systematic is a good sampling method. The only one we haven't done right here is randomly select 200 parents, and truthfully, they would be all enumerated. So we'd have a list of parents. We'd randomly select 200 from the random numbers of parents. And then we're going to follow up with a home visit to make sure they respond. We're not going to get non-response bias. So randomly selecting from a list of all the names that are, like randomly picking just certain numbers or certain names, randomly picking is going to be a what type of sample method here. We're not picking the first 200. We're not acknowledging differences. We're not taking all the parents. This would be a what sampling method? A, B, C, or D. So you guys got to help me out with the sampling. It's good job. Some people have been helping me out so much. Exactly. So it's all the names they're picking from everything. It would be a simple random sample. And then we have bias would only occur if they do not follow as described. I think we got everything correct. Woo! See, I'm like, I could read over it like 10 times. If I was taking this quiz, I would be double checking it. But it's very easy to make mistakes. The only one I was worried about is this one right here with the convenience. I mean, it gets iffy on like there's a few ways it could occur. That was the only one I was like, hope that one's correct. Because it's just sometimes my Pearson will put an answer where I'll be like, yeah, I'll agree with that. Remember, we got 5 points on this quiz. What was it? I think chapter 12. Layla, you wanted next. Layla's question was next. Let's hop over to the... So chapter 12 is next. With chapter 12, which question were you wondering about on chapter 12, Layla? Let's hop to chapter 12. And HelloFresh wants me to buy their food. I'm not buying any HelloFresh food. Chapter 12. A little music. We'll put on Celeste. And we'll let Layla pick the question right here from chapter 12 quiz. I went to the preview by accident. This makes me want to play Celeste now. And there we go. Let's take a look. The plastic arrow on a spinner for a child's game. Let's do this. Turn the music down a little bit here. And let's do this. Oh, no worries. What are the rules for probability? What's the first rule of probability, which you'll notice up here is broken? The first rule of probability is all probabilities must be contained between what and what. The first rule of probability is all probabilities must be contained between what and what. The first rule of probability is all probabilities must be contained between what and what, which this breaks the rule. The first rule of probability is 0 and 1. So these are not possible. Just going off of this first spinner right here. And I'll show you how some of these spinners look. We can't draw this one. It's just not possible. Since the probabilities, at least one probability is not between 0 and 1, this is not possible. Now the second spinner right here, I want you to envision it in your head. This is telling you the probability of landing on a certain color of the spinner. So what should this spinner look like when I draw it? I just want you to see this when we're talking about this spinner, spinner number B. Just describe spinner number B to me. Spinner B would look like what? It would look like a spinner. So we got a little spinner wheel with like a little thing where it shows you what color you picked and you spin the wheel. And the wheel looks completely... yours might be 4 parts equally colors. The spinner C is. Spinner C is, but spinner B is completely what? Spinner C, so this is our B, spinner B is one color. Spinner B is one color. Now the next spinner, which you just pointed out, great job right there, we got this, is, and these might be the colors, the next spinner wheel is equally 4 colors. So this is spinner C. So both of these are possible. Spinner B is just a completely, yeah, it'll change the order on them. I was like, my spinner B is just all yellow. My spinner C is 4 equally partitioned colors. So this is possible, and this is possible. And so each probability is between 0 and 1, and the probability is sum to 1. That's the second rule of probability right there, is that the sum of all events adds up to 1, that if you list out everything. And so that basically means it's good. And then you should have is. Like if you select this, you have to select it is possible. And then the next one down here for D, what do you notice about D? The sum of these probabilities right here is what? So it's not possible. The sum of the, like this is 50% red, 30% yellow, 10% green. Uh-oh, that's 90%. And then 60% blue. Well, so now the probabilities sum up to something greater than 1. The sum of the probabilities is greater than 1. This last wheel might look a little bit weird, but it's totally possible. This last wheel is possible. It's just a wheel that's mostly red. It's 50% red, 20% yellow, 10% green, and 20% blue. So we should draw it out here just so we can see what it looks like. Did I say 50% red? Great job, Layla, right there. So it's 50% red. Did I say 10% yellow? Oh, wait. There's the, yeah, there's 10% yellow. That's about close to what the wheel looks like. That's about close to what the last wheel looks like with being 50% red, 10% yellow, 20% blue, and 20% green. Maybe my percents are a little bit off right there. But the last wheel has like the proportionality of that, and that is very possible. Each probability is between 0 and 1 because probabilities have to be contained between 0 and 1. They can be 0 or 1, but they have to be contained between, and the sum of all probabilities is 1. There we go. We haven't gotten a question wrong in like 2.5 days. We're not going to get any more questions wrong for the rest of the semester. I think I was just lacking coffee, maybe. Is this making more sense? We can do another one, Layla. This one was pretty quick. If you want to knock out another question, then we'll open up the floor for more questions. Do you have another question? You said there was you said honestly all of them, so we can do another one because we just did this material today. So I was like doing things that like are like we just did because then you're like, oh, we did this during class. So hey, let's check this out during office hours. And we can, yeah, we can do. Which one do you want to do? Just pick any question you're currently on, and we'll explain how to do it. And this is just going over the rules of probability right here. That probabilities must be between 0 and 1. They can't go lower than 0. They can't go above 1. And then when you sum up all the events or all the occurrences, we would get the sum of all the occurrences. A consumer, yeah, let's do it. When you sum up all of them, you have to get 1. Like there has to be 100% probability when you sum up 25, 25, 25, or 50%, 10, 20, 20, or 100% and 0 for the others. Consumer organization. A consumer organization. Estimates, ooh, is the car one. Yeah, let's do the car one. That's a tougher one. So I think there's 2 of them. Make sure, which one do you have? Do you have version A where it says no repairs, or do you have version B where it says neither will need repairs? Here's version A. So type A or B in the chat. We can do the A or B version. We'll require, wait, what is it? We'll need, I think I can tell from here. Will need to be repaired once. Oh, no, so it's the end of it. Do you have the no repairs, which is version A, or do you have this, which is version B? Because there's 2 versions of this question. So here's version A where it says no repairs, and here's version B where it says, version B, where it says neither. Okay, let's take a look at this. Okay, these are the trickier ones, so let's do it. Let's draw this out. The best way to do these is to draw this out and see what it's asking. Okay, so we're going to take the question, hop over here, and then the floor is open up. So I know Ritu and other people, AJ wanted us to work on the project a little bit. The floor opens up after this, so put your questions out there. Ritu and everyone be like, hey, Brian, can you work this problem? Can you explain this about the project? And we'll hop to that next. So floor is open definitely for the next question. I could put a ticker on the bottom of the screen. That might be annoying. I don't know. I have ideas. Like it could be like next question, so-and-so, and I could edit the thing to be like so-and-so's next question. I don't know if that'd be good or not. Chapter 13, part 2. Pick which question you want to do, and then we can do that next, Ritu. You got it. I'll just be like, do the question that covers this, and then we'll do it. So a consumer organization, 15% of cars will need to be repaired once. So the probability that a car needs to be repaired once is going to be equal to 15%. The probability that a car needs to be repaired twice is equal to 9%. And the probability that a car needs to be repaired 3 or more times is equal to 4%. What do you notice is missing right here? You're talking about are you talking about the quiz? What do you notice is missing right here, Layla, that they don't give us? We have the probability that our car needs to be repaired 1 times, 2 times, or 3 or more times. And I'm saying or there because we can add those. So what are we missing with this question right now? Your car either needs to get repaired 1 time, 2 times in a year, or 3 or more times. So we're missing something right here. There's something on the probabilities that's missing. There's a probability they didn't give us. And I can solve for it over here that it does not get repaired exactly. So the probability your car does not get repaired. Here's the probability your car gets repaired. There's the probability, that's the probability it gets repaired. And that's the probability it does not get repaired. So the probability of getting no repairs is equal to the probability of it not getting repaired. So because it didn't get any repairs. So now we have all the probabilities listed. If you own 2 cars, what is the probability neither will need a repair? So your first car did not get repaired. Your second car did not get repaired. What word should you put between your cars when you talk about my first car did not get repaired, my second car did not get repaired? My first car did not get repaired, my second car did not get repaired. What word should we put between those when we solve this here in a moment? My first car did not get repaired, my second car did not get repaired this year. Vitamin D, you got it. My first car did not get repaired. My second car did not get repaired. So what would we put between that when we talk about calculating the probability that both cars neither get repaired? The first did not get repaired. Then what goes between that right here? First did not get repaired. And then what word would go between it? We would use and. My first car did not get repaired and my second car did not get repaired. So for this first question right here, where we have my first car did not get repaired and my second car did not get repaired, we would go right here and we'd do the probability of 0.72 times 0.72. So the first, yep, great job, Layla, right there. First did not get repaired and my second car did not get repaired. So now the probability that they will both need repairs, now you have to be careful. This is where they're trying to get tricky. Here's the probability of repair. So I'm just going to put a probability of repair right here. So now the question becomes, what is the probability that my first car needs to get a repair and my second car needs to get a repair? Because when you add these together right here, either your car needs no repair or needs a repair, which might need 1, 2, or 3. So what's the probability that your first car needs a repair and your second car needs a repair? So go ahead and be thinking this through right here for the probability your first car needs a repair and the probability your second car needs a repair. So the probability your first car needs a repair and your second car needs a repair. Because we have the probability of repair right here. So it will be the probability of your first car needs a repair and your second car needs a repair. So this one right here is going to be the same thing that we did a moment ago, but I'll put this over here. There's the and. We're just going to change the probabilities right here. There is the first does not need repairs and the second does not need repairs. The first did not need a repair and the second car. Yep, great job, Layla. Excellent work. The probability that at least one car needs a repair. Okay, this is where it gets, this is the tough one. So with this one, would you agree either neither car needs repairs or at least one car needs repairs? So either neither of my cars need repair or at least one of my cars need repairs. So it'll be true that either neither of my cars need repairs or at least one of my cars need repairs. So this is going to be the probability of neither or the probability of one or more of my cars need repairs. And then I'm going to change this or to a plus sign. And now the answer should start to be there. Well, we can't add up all the numbers because we're saying, well, that would be the probability. So that right there, I think you might be seeing it, Layla. Because either neither of my cars will need repair or one or more of my cars will need repairs. The mathematics that you just, so add, not multiply. Well, so you might see it. Do you see the answer? What you just put in the chat, which definitely great work right there, is the first card does not need repairs and the second card does need repairs. So that's the first card does not need repairs and the second card does need repairs. So what will this solve out to mathematically? And do we know the probability that neither of our cars need repairs? Have we solved out for the probability that neither of our cars need repairs? Because we have that either neither of our cars need repairs or at least one of our cars need repairs. And one of those things must occur. Either neither of our cars this year will need repairs or at least one of our cars will need repairs. So what will this solve out to mathematically to figure out the probability of at least one of our cars needing repairs? Let's just do this. Take this over here and bring it over here to this side, mathematical. So yes, that is great job, Layla, right there. That is correct. We found this out earlier. We found this out for question A. So question A has the answer for neither, and that's going to be 0.72 raised to the second power. And there's the answer for the probability of at least one of our car needs repairs, because it's everything but neither of our cars needing repairs. So this is not neither of our cars needing repairs. It's the complement of not needing repairs for either car is needing repairs for at least one car. Does that make sense when I say it that way, Layla? That the complement of not needing repairs for either cars is at least one car needing repairs, because either neither of our cars will need repairs or at least one of our cars will need repairs, one or more of our cars. So that should do it right there. That should be the answer, 0.72. I'm just trying to put in my head so when I solve this out here. And then we're going to do Ritu's question. 0.72 times 0.72, there's that one. Do not round the answer. Both cars need repair. 0.28 times 0.28. There's that one. And then we're going to take this one right here, and we're going to go 1 minus. And there's that one, unless I have not copy-pasted. There we go. Awesome work. That is a tougher one. And hopefully understanding it conceptually right there, that's probably one of the toughest ones on the homework. So if you're able to do that one, if you solve that one along with us, you're perfectly on track. That is a tough one. So that's one of the tougher ones, just knowing the mathematics and knowing what to do with it. Practicing your rules, just so people can see here again. Let's display the rules on the screen. Here's all the rules when it comes to the complement, everything but 1 minus. And then the addition rule, things need to be disjoint or mutually exclusive. Your car can't not need repairs and need repairs. And multiplication is when we multiply independent events. Theoretically speaking, that problem might have a problem, because if one of your cars needs repairs, you'll use the other one more. So there's a little theory problem with that question. Ritu has a question. Let's hop over to it. Ritu is doing chapter 13, part 2. Let's hop to that. Great job, Ritu. Excellent work. Let's go do that. And remember, the floor is open after this one, so put your questions in the chat. Chapter 13, part 2. We'll be covering this tomorrow. This is a tougher chapter. Here we go. Let's see. Go to the chat. And let's check this out. Let's hop over to the main screen. Vitamin D, whether ingested as a dietary supplement or produced naturally when sunlight falls on the skin, is essential for strong, healthy bones. The bone-dense disease rickets was largely eliminated during the 1950s, but now there is a concern that a generation of children more likely to watch TV or play video games than spend time outdoors is at increased risk. A recent study of 2,800 children randomly selected found, that's good. Randomly selected found 23% of them deficient in vitamin D, complete parts A through C. Now, what's interesting is, as I was alluding to this equation when we were doing our chapter 10, in chapter 10, I showed the equation we were using, and did I not do it in chapter 10? There it is. I knew I did in chapter 10. This is the equation we're using right here. I wish I could rewind time on it. So we need to know this notation. This was alluded to in class. We haven't taught it yet, but this is the equation we're using. The equation we are using is p hat plus or minus the z-score times, that's a star on the z, p hat times q hat over n square root. So this is the equation to find a confidence interval for the true proportion. This also goes with what we've been doing in class, where we've been talking about samples. We'll hop over to this screen. Where we're talking about a sample statistic gives us an estimate of the truth right here. The truth is the true proportion. So we're going to use the sample to make an estimate about the truth. So let's go ahead and take a look at the question and see what they want us to do. Whenever we have a question like this, we need to mark the notation. So I'm going to need some help here, Ritu. I'm going to need some help. I need you to help me with at least one of these values. I'm going to write the equation for you while you look it over and tell me at least one of these values. These questions right here are all about identifying the notation. So I'm going to circle the values, and then I want you to tell me what at least one of the values is. So here I'll start circling the values. Okay, we have this. We have this. And I think that's about it. So now we have p hat plus or minus z. And we don't know what z is yet. So what is one of those values right here? So what is one of those values on the screen right now? What is one of those values? And then we'll talk about what the notation means. I'll explain what the notation is. So n right here, I'll highlight it. N is the sample size. N is the sample size. P hat is the sample proportion. Q hat is the complement of the sample proportion. So it's just 1 minus it. So we just talked about the complement today. P hat and Q hat add up to 1. So if you know what P hat is, Q hat is just 1 minus that. And so P hat here again is the sample proportion. And then Z is going to be relative to the confidence interval. Close. So the 23% is going to be P hat because that's what we saw in the sample. So if this is equal to 23%, what is Q hat going to be? Yes, that's the sample size. Great job, Ritu. Excellent work. Let's throw some 50 points out there, Ritu. Great job. And this is the notation we need right here. N is going to be the sample size. And so great job, Ritu. And so what is Q hat? What is Q hat going to be? Q hat is the complement of the sample proportion. Yeah. And feel free to ask questions, AJ, whatever you're wondering. Whichever thing you want to start on, just be like, how do I make a bar chart, pie chart, questions on this or that? Just say, can we talk about this? And we'll do that next. You got it. We're going to do this question, then we can do that next. So how would I find Q hat right here? The Z is going to be a little more complicated. We'll talk about that in a moment. Exactly, Ritu. It's just the complement, which is a good review of the chapter we were just doing. It's just 1 minus it. So all you do, which, you can solve it in the calculator if you want, but you just go right here and you do 1 minus this, and there's the answer. So Q hat is just the complement. Now the Z is where things get a little bit complicated. The good news is we got Mr. David M. Lane to help us out, and he's supposed to be sending me his Java applet. I hope he does. I emailed him and he said he'd send it to me. It's his. He doesn't have to do that. Maybe he's like, maybe I shouldn't send this kind of thing. But I want to work with it. He said it's in JavaScript. I contacted him and he was like, very nice to hear from you. And it's his. He can do whatever he wants. But I'd love to work with this and start seeing what I can do with it and learning it. I'm always wanting to learn and change things and make my own versions. And, I wouldn't post it anywhere if he doesn't want to post it because this is his website. He's got the advertisement down here. I looked at the Precision Consulting and they're really cool. Their website's pretty interesting. It's got a lot of animated stuff on it. And I was like, that's really cool. Makes me want to, I'd hire them if I needed consulting. So what we're going to do is we're going to go to this area right here. And this is what a confidence interval looks like. And I want you to tell me that value right down here, Ritu, is very, very close to what? What do you notice about this 68% confidence interval? Ritu, I'm throwing you another 50 points. Yes, you know how to do it. You know how to get the Z-score. You're exactly right. 2.5758 is the Z-score, and you notice this is based on basically the 68, 95, 99.7. So Ritu, you figured out how to do this part. Excellent work. This is where you enter in the percent confidence. Oh, that's a 99% confidence interval. Trying to think how you did that, but that's the 99%. So you might be doing a 99%. That's the Z-score for a 99%. 2.3263 is the 98%. So since I'm doing a 98%, there's my relative Z-score, and notice how it goes further out the more confident you are, which makes the interval wider. It's going to make it wider the more confident you are. Is that making sense here, Ritu, how to use this and to plug in the values, and you want to cover a certain percent of area and get the Z-score relative to the area covered on the curve, whether you're wondering for a 68, which is close to 1, 95, or 99.7, which is going to go out more and more standard deviations, and then the Z-score is just going to be how many standard deviations we go out. So you have to go to the David M. Lane applet or use a table. I like the applets because they're more exact, and you can just be like, I want a 95.449% confidence interval, and wow, that's basically 2. So that's where 2 is actually at. 99.73 is where 3 is actually at. Oh, I can't do that. There we go, right there. Luckily, mine was 98 as well. Yeah. And then you can just plug in the numbers right there. So you want to use 2.326, and then the next number is 3. Okay, so we're going to plug that number in here. The z-score is obtained from the David M. Lane applet. Z equals 2.3263. And we're going to take that number and put questions you have in the chat. So AJ, if you're wondering about the project, which part are you working on? Which part? I know you're saying the student. So which thing are you working on? What do you want to analyze? What questions do you have? Drop those questions in, because we're going to be working on that here in a moment. Just drop questions in like, I want to analyze this. I want to understand this. I want to make a bar chart of this. And then we can go ahead and start doing that. I'll delete the 3 off of there because it doesn't show that on the applet. It is the next number, but it doesn't show it. I've just looked at those numbers a little too much. So the best way to solve this, the best way, what's the first thing to do on the prompt? Basically just selecting, here, we'll go and look at that. So like, you just want to kind of think about what you want to analyze. That's the first thing to do, is like look through the data and be like, what company am I working for and what do I want to analyze? Like, what do I want to investigate? What interests me about this? Like, you can come up with whatever you're working for, whatever company, whatever you want. You just think, what am I analyzing? Who is this for? 0.77 divided by 288. I'm solving this part of the equation right here. Now, we have just solved for the margin of error. This right here, oh, I didn't square root it. I knew something was wrong. That was too small. Oh my gosh. Okay, there we go. Sorry. I square rooted it, but I squared it first, so I undid that. Okay, so this is the margin of error. This right here, everything right here is the margin of error. That's the plus or minus on an interval. Like when you hear a poll, when they say someone's approval rating is like 55% plus or minus 3%, that's the margin of error that we're calculating right there. So it's the plus or minus, it's the uncertainty. So with the margin of error calculated, well, we're good to go. 0.0185, 0.0185, 0.0185, 0.0185. That's got it. And then all we're going to do is add and subtract. Your answer is around, the decimals seem, you should get something close-ish to this. You might have had a decimal error. Let me show you again how to calculate this. I'll do it slowly. I'm going to do p hat times q hat over n. There's p hat times q hat square root times by 2.326. And there it is right there. P hat times q hat over n. You should see something similar to this. Are you getting something? Is yours? Oh, you added? Yeah, and then you will add and subtract it. So you will get a lower and upper bound. So you'll go here, this plus this, and this minus this. So you'll go 0.23 minus this to get the lower and the upper bound. Does that make sense? So you're going to go plus or minus this to get the lower and the upper bound. So the answer is going as low as 0.2115, and the answer is going as high as 0.2485. That's got right there. My answer is now this. Yep. Should be similar. Ask. Should be close-ish to it. So we just found out the confidence interval, and 98% confident. Here we go right here. And does it want decimals? 3 decimals. Okay. So this one was 3 decimals right there, right? And then 248. Is that the full problem? No. Interpret what this interval means. I am 98% confident the true proportion of children with vitamin D deficiency, because that's what we're talking about, is contained in the interval. The true proportion of children with vitamin D deficiency. I hate that they would use the word fall right there. That's really not a good statistical word. I was like, that's the only one. About 98% of random samples of size 2,800 will produce confidence intervals that contain the true proportion, because that's our goal for a confidence interval. We're trying to estimate from this sample of children, we're trying to estimate the true proportion of children with vitamin D deficiency. In our sample, we saw 23% of children with vitamin D deficiency. We think the true proportion of children with vitamin D deficiency is about 21 to 25%, and we're 98% confident. I did extend the interval a little bit, but if I'm talking to executives about this, I'm probably just going to say, it's probably about 21 to 25% of children have vitamin D deficiency. So maybe around a quarter of children have vitamin D deficiency at most. Kind of an upper bound for our interval of what we believe could be true is 25%. So we know less than, it's definitely less than half the children have vitamin. It's not good that a quarter of them could have it, but somewhere between 21 to 25% ish, because it's not exactly as 21.2, 24.8, but I'm going to round it talking to executives. Nice job, Ritu. Excellent work right there. Great job. And then confidence intervals in the long run contain the truth. This is actually a comment on the law of large numbers that if you keep making confidence rolls, 98% of random confidence rolls collected from sample sizes of 2,800 will contain the truth. That's just what confidence rolls do in the long run. AJ was wondering, what's the first thing to do with the prompt? Let's head over here and let's talk about the project real quick. Okay, so we've got the student data set we're going to take a look at. Let's bring up the student data set here. So the first thing you want to do, really? The variables are all scrunched. I'm going to make the variables look a little bit nicer. I'm pulling up the student data set. Oh, because I copy? I didn't think I made them look like that. I thought they were looking a lot nicer. Okay, let's talk about the student data set. So what you want to do is you want to think like you're just working for a company right here, and they give you this data. They say, we're analyzing UT students. You can actually click on one of these students and read about them. So this student right here was a female, 72 inches tall, 160 pounds, wants to weigh 155, GPA at 3.7. Here's all their information. And what do you want to analyze? We'll put this right here so we can just see this. What would you want to analyze? What variable is interesting here? What variable is like, that seems like something worth, like just examining. So we've got how attractive they think they are, how intelligent they think they are, how athletic they think they are, how funny they think they are, if they're dating someone. On Canvas goes up to exam 2. So it's not letting me drop the quiz. It's supposed to be like that. I think that's what, that goes up to exam 2, so that is correct. So there's one drop for exam 2. Is that what you're asking, Ritu? So there's one drop for exam 2. So that is accurate. We have how far they moved to campus. Well, so there's one drop. I can double check everything and make sure it's all working correctly. So there's one drop for exam 2 for the quizzes. And so whichever is your lowest quiz for group 2 will be dropped. Just tell me if it's not working properly and I'll make sure it's working properly. We have how many piercings they have, how many tattoos they have, how long they're on Facebook a day, how much they text per day. We should, if we updated this would be like Instagram. It should be dropped automatically. I can check that here in Ritu next if you want. I'll make sure. It might just like have not updated. Like you might have just taken it and it might not like be updating. And sometimes it takes a while to like send the things between Pierce and Canvas. I don't know why, but it might, I'll push through an update. I can push through updates like to force it to update. And then that sometimes like makes it calculate the grade book correctly. But it does it like, it might just like do it at certain times. Maybe so it's just not hitting their server all the time with updates. It might like once an hour update it. I've never figured out when it updates, but I know it does. Sometimes it just takes a while. What would you be interested in analyzing, AJ? What would you want to understand about these students? Like at least one question. What company do you work for? Like what company do you work for? What do you want to understand about these students? What variable of interest, at least, and there can be a few. You can work for any company. You can work for any group. So what company are you working for and what do you want to analyze? What do you want to understand? Snowden Inc. Is that Edward Snowden Inc.? Maybe it's a privacy thing. So you could look at some social media stuff right here. You've got like how much people are using text, how much people are texting, how much people are on Facebook. So GPA versus number of tattoos. Well, and that'll be, what graphic would you make if you're looking at GPA versus number of tattoos? So you could analyze GPA versus number of tattoos, and you could see if someone's GPA, and so you could do this. Which graphic, and it's probably going to look like this right here. It's going to be a lot of people with very few tattoos. Then you have some people with a lot of tattoos, And you're probably going to see something like this. This is my guesstimate of what you're going to see when you do this. So what graphic do we have here with GPA and number of tattoos? And this can be done for this project. You can analyze the people's GPA by number of tattoos, and that's probably a pretty weak relationship. Scatterplot, great job. So this would be the two quantitative variables scatterplot portion. So you could see if tattoos explains people's GPA. You could reverse it, but I would think it makes more sense to say, do people with more tattoos, and it might go slightly up or down. I don't know. I think it's going to be pretty weak no matter what it is. And you're going to see here a not so significant relationship, which is fine to see. I'm not grading on like, do you find low p-values? I'm grading on, can you analyze this? How can I make the graphics? So to make this graphic right here, we've got the data open in Jump. Do I still have it open in the background? Yep, here we are. To make this graphic right here, we go to Analyze, Fit Y by X. And so I'll send you the playlist right here that has all the step-by-steps. But if we want to do number of tattoos, and then we want to predict someone's GPA, we go right here. And, oh, looks kind of like I thought it would. Does it go slightly up or I think slightly down? Slightly down. Look, my gosh. I'm sorry. I'm not going to pat myself on the back, but oh, the first line I drew, I can't make it reappear, was something like this right here. And I'm just saying that graphic right there looks a lot. I mean, that's very proud of myself. Good job, Brian. But this is pretty weak. Yeah, it's actually almost statistically significant. And we see here that it really doesn't explain any portion of the variation. And it's probably due to maybe some outliers. The person with a 0 actually pushing in the other direction. But I don't think this is a very strong or significant. It's not statistically significant as per the p-value down here on the regression tells us that this is not statistically significant. The slope is the p-value. And we need to include output like this right here where we talk about the r-squared. And we need to include output down here where we talk about the p-value on the regression telling us whether or not there is a statistically significant relationship. And there is not a statistically significant relationship. And if you hover over it, you have to sometimes spin over it and you'll say like it's not statistically significant. It says weekly? Ooh, Jump, you should not be saying that. At the 0.10 alpha level maybe, but they shouldn't be saying that. If you're looking, so I've got step-by-steps for each graphic on the project. Let me get you the project playlist. So the project playlist, which is right over, here is the project playlist. And I'll send you to the, let's do bars and pies. Here is the project playlist. So after the prompt, I wouldn't write my executive summary yet. So let's go look at the project itself. I would not write my executive summary yet. I would not be like, I'm going to start writing my summary because the summary is a summary of the project. Can you go example what you want interpretation of it? Yeah. Which one, Layla, which one do you want interpreted? And then we will do an interpretation of one of those. So feel free to tell me, Brian, interpret a blank, and I will fully interpret a blank, and I'll even write it out. I'll take some pictures. I'll do a full interpretation of one of those. And I like that we have multiple data sets. That way I can kind of do a portion of this one, a portion of this one, and everyone can fill in the other gaps, but you can see some of the work done. I lost my place. If I was starting this project, you do not want to write the executive summary to start, because the executive summary is a summary after you've completed the project. So if you go here to the instructions are going to have for you, let me close, there we go. The instructions are the scatterplot and histogram. Yeah, you want to do histogram? We can do pretty quickly. Can you example? Yep. Let's do the histogram one. So if you look right here, there's the prompt. Make sure to turn everything on time. If it's past 11:59, it's late. I would go down here to your bars and pies. Histogram I understand more, but there's a good bit to talk about on the histogram. Let's do a full interpretation of a histogram. All right. Would you rather do a scatterplot? I can do a scatterplot. I can do the one we just did probably. So we can do a scatterplot instead. So what I would focus in on is all of this right here where it says bars and pies. You're just going to pick a variable you're choosing and start analyzing it and make a pie chart or a bar chart of it. It does say bars and pies. I should have put maybe bars or pies. But yes, scatterplot, let's do it next here. So you're going to go through and start doing these. Make sure to read over what the instructions say. They're pretty short and pretty to the point. Like when it says, when interpreting values like the mean, standard deviation, median, or IQR, make sure interpretations are more than the mean is blank or the median is blank. Interpretation should bring context to the data and not just cite values. That's very important right there. I'm probably going to read some projects where it says the mean is this, the standard deviation is this, and that's all it says. We're going to give interpretation. We're going to give context. So when we read the scatter plot, let's go ahead and take the prompt as though we're working on the scatter plot. And we're just going to drop the prompt right in here and use it as a guideline for what we just created. Yeah, well, you can get some scatter plots that are not too great looking. It's all right. Like, it's no big deal if your scatter plot looks like this. Let's go ahead and take this scatter plot and take the important information and follow through on the prompt and see what points we would get. We don't need the linear fit right there. Not the end of the world if we get it. That's a good screenshot. Good deal. We're going to decrease the size of this. Always kind of be cognizant of how big it is. Don't include the prompts. Do not, I'm just putting this here for reference right now. Do not include the prompts. I will take off neatness if you include the prompts. I should have made that more clear maybe, but don't include the prompts. Yeah, that's excellent right there. That's great, Layla. Perfect. That is exactly what I want. The mean represents the overall average GPA, which is blank. Yeah. You don't want to just say the mean is this. Just tell someone the average GPA. That's a great way of communicating it. The mean represents what we saw on average for GPA, and this is what we saw for the mean. That's more communication than the mean is this, the median is this. So that's the full interpretation. Not a lot to interpret the mean, but we should give it context. So we have describe, create a scatter plot, and add a regression line through it. Boom. Now, if you notice right here, we have interpret the R squared. I should have told everyone to include I do mention this in the rubric. I do say include numeric values for this. I wish I'd put it there also. And I have told a few people when they've sent me their project. But if you go here to the regression portion on how it's graded, graph is well displayed, easy to read. Make sure to include numeric backing by adding numbers to the graphic. So you need to include numbers when you reference them. Please include your numbers. So I'm going to go grab the numbers right here. Whenever you mention numbers, you should be talking about them. Let's go right here, grab this. We need this. Oops. And there's that. You know what? I kind of like this. I kind of like how this is next to the graphic right now. That's, I might make it a little bit smaller. That works. I'm good with that. And let's go ahead and grab this right here. And go down here to the very bottom. We need this also because we're going to mention the p-value for the model. And I think this is a pretty good layout of results right here. That I'd say, what you do. So I'd say this is a pretty good layout. You can always do crazier things. You can go up here to the picture options and start adding, a little shadow or drop shadow. It's not a bad idea. Well, look at that. I think, someone might say that's not good. You shouldn't do that to your pictures. Well, whatever. Yeah, the parameter estimates, because we're going to be mentioning this p-value down here. So anytime you mention a value, make sure to have the value. I'll probably be nicer on this one. I might mention in the comments. Maybe I think I'm going to do that since I didn't make it explicitly clear, but I'm going to feel bad if I'm taking off points when I didn't make something clear enough, because that's never my goal to be not clear. But I'll mention this for the next project. Like, if you're talking about a value, you need to have that value. So I don't think I should take off points for this, because I don't want people being like, I did what you said. And I'll be like, but the rubric says this, but the assignment doesn't say it. But I might put this in bold at like the start of everything. Like, even if not mentioned, whenever you cite values, like if you are mentioning a value in your report, like R squared, you need to give R squared. If you're mentioning the p-value, you need to give the p-value. So describe the relationship in the scatterplot with the strength, direction, form, unusual features. I could say the relation, ooh, it put a border around that. See, I'm going to get some points off. Don't do that. It's got that large border. Wait. There we go. All right, cool. Okay, that works. It had a really large border, and it was cutting off. I was like, I thought I took a better screenshot than that. That looks good right there now. Be very careful. You could do something like I just did, and I'd be like, your picture's cut off a little bit. I could take off a point. The relationship. Number appears to be very weak. I'm going to get the r squared for this. Be very careful. The r squared, we're going to take this r right here, and we're going to square root it. And so the r squared, the r is, the two variables have a correlation. Let me just go down here so you can see it. I'm going to delete myself. The two variables have a correlation of negative 0.07. Overall, the relationship is negative and somewhat linear. There are a few extreme outliers, like the individual with no tattoos and a 0 GPA. So what did we just do right here? We just described the what. So with this right here, as I was talking through this, I have the strength, direction, form, and unusual features. Strength. That is right here. I'm saying it's very weak. And I'm noticing that by basically, you can do it via the correlation right here, the absolute value of the correlation, which also is negative, which is the direction. Overall, the relationship is negative. It goes downward. It's somewhat linear. It's got a little bit of a bend. It's somewhat linear. It's fine to say somewhat linear. You could say it's linear, but it's somewhat linear. There are a few extreme outliers, and that is your unusual features. So we just went through strength, direction, form, and unusual features. So now we have to interpret the r squared of the regression in context. So the r squared of 0.004904 tells us that only 0.4904, we're timesing this by 100 right here, percent of the variation in GPA is explained by the variation in number of tattoos. So r squared is the percent of variation in y explained by the variation in x, so we're good on that. Interpret the p-value of the regression and what this means for someone who might not have taken stat tool 1. The p-value for the regression is not statistically significant since 0.03 is above 0.05. This means the relationship we see between GPA and number of tattoos might just be due to random chance. This leads me to believe there is not a real relationship between these two variables. And Layla, guess what we've done? That's it. And this is awesome because what have we just done in this portion? How many points have we gotten in our project? So I would delete this. This is not meant to be included right here. But how many points have we just gotten for our project right here? How many points, if you saw briefly right there, how many points did we just get for our project? And then keep asking more questions about the project. But I'd say this looks pretty good right here. This is a pretty good section. Oh, that's awesome to hear. I'm glad that helped. Just keep asking questions. Be like, hey, Brian, can you work through this? Like, I'm glad we can switch data sets. If I do something else for another portion, I'll probably do another data set. But just going through, interpreting the r squared, interpreting the p-value, kind of mentioning what it means. Because, like, what does this mean? Like, it's not statistically significant. Well, that's what a p-value above 0.05 means. This means that the two variables, this line right here is probably just random chance. They're probably not related. There's probably not a linear relationship. How do you get numbers on the bar chart to show up? Which one are you doing, AJ? You're doing, are you on Jump? Are you on PC or Mac? Weird question, I know, but there's an issue with Mac sometimes. So Mac sometimes on night mode has a little bit of an issue. So let me see. You might be running into the Mac night mode issue. So how do you jump on a Mac? Okay. And if you're in night mode, my contacts are going crazy. Contact, come on. Bar chart, right? How do you get numbers on a bar chart to show up? So let's go to graph. I might have to show you the video. I believe you have night mode on. Did I put that? Let me add that. Here we go. Found the video. If you're having a video issue, summer mini project. Okay. Cool. I'm moving it around now, so it's. I'll show it here in a second. Ah, there we go. That should. Let me put it here. There we go. And let me move a few things around. Creating pivot tables. That should be here. And there we go. Cool. Okay, let me show the video. And so, AJ, I think this is the issue you're running into. Correct me if I'm wrong. So I think that's the issue, AJ, right there. I think the issue is the night mode issue. And so you want to go there to the Apple. Here, I'll mute myself on this video. You want to go to the Apple and you want to go to System Preferences. And once you're in System Preferences, you want to go down here to, is it General? You want to go to General and then just switch it over to light mode. It's just that dark mode right there does not allow, I don't know why, it's just an issue sometimes. But yep, that looks to be the issue. Did that fix it right there, AJ? How's that looking? Is everything working? And I added that to the playlist right here and I moved some videos around. But that's in the playlist now in case anyone has that issue. So people should be good on that issue, or it should work now, I hope. What questions do people have? Let me know. You still can't see the numbers? Let's check this out here. Let's go over to the student data set. With the student data set. So, and you said you're doing gender for the Mosaic plot. Here, we'll do Mosaic plot next. Great questions, Layla, right there. Awesome work. I'm sure it's going to help people out looking at this video. Let's go over to, you can do it in Graph Builder. So you said you were doing gender, right? You want to take gender and drop it down here to either one. That's fine right there. You want to go here to the bar option. And now you have kind of a bar chart. But we're going to go down here. I'm going to decrease font size, or not decrease font size. There we go. You can see down here at the bottom, it should have label. I'll make it big so we can see. So we have label, and with label right here, we're going to go to no labels, and we're going to label by value. You could do label by the value or label by the percent. Oh, it's not showing me my percent of values? What you doing, Jump? Where's my values at? That's weird. Yeah, it's not showing it for me there either. Don't worry, label by percent of total values. It should show it. Let's start over and see if that works. I'm going to just drop this variable here. Now let's go to bar chart. Label by percent of total values. That's weird. Well, the good news is we can just put the values over it. Mine worked. Yeah, I don't know what's going on with mine right now. Why is mine being weird? I make videos on how to do this and it doesn't want to do it. Let's start over. Let's try doing a pie chart of it and see if it does it. That's weird. So let's go to a pie chart. And then let's label by percent of total values. There we go. The pie chart's doing it. Let's switch it to a bar chart. And the bar chart says no. So the pie chart does it. The bar chart does not. I have no idea why. I need to tell Jump and be like, hey, what's going on right here? Yeah, that's weird, isn't it? I put this right here? No. I don't know. You could also make a bar chart by going to the following, by going to Analyze Distribution. You could also pick Handedness right here is another way of doing it, and you actually get the same sort of output, and this is a bar chart. So this is perfectly fine. And a secret thing you could do, which you don't have to do, but you could have always gone here, and this is not shown in any of the videos, you could go over here to Pareto plot, and you could pick the same variable, and now we get a Pareto plot of it. There's the Pareto plot. And you'd probably need to add in the percentages. So usually the red arrow. Oh, no, we don't want that. Label. Well, that's a bummer. Yeah, it's not showing them. I'd probably accept this. I don't know. I'd probably. I don't like this graphic nearly as much. This one's fine. This one's, of course, we need the numbers, so we'd go here to the pie. I've got data selected, so let's deselect that. And now we go to this. This is perfectly fine. Go ahead and click done. Don't turn in a graphic that crazy big. Let's decrease the size of this window and turn in something more like this right here. This is a good acceptable graphic, and this is kind of what you're looking for on the size. Apparently I still have data selected over there. And Layla said, for a mosaic plot, if one side of the plot is bigger than the other, that means that there's more of that specific thing, right? Like if females was wider than males. Bingo. Great job, Layla, right there. Let's go ahead and look at one of those. For a mosaic plot, we don't have many options right here. So you might have done this one. I might be picking the exact one you did because there's not lots of options. Let's go here to gender, significant other, and then we're going to analyze this. And you can see that female's a little bit bigger. Now, a mistake that's going to be made is a lot of people are leaving in the total percentages and the column percentages. So you can see right here who was more likely to have a significant other. When you look at these percentages, the males who did not have a significant other was 60.70%. Is that what I said up there? Okay, about the percentages in the description instead of on the graph since it wasn't showing up. Oh wait, so you have it in the description. I think so. So let me see here. Mine worked. I did it the other day. Wait, I put my percent. Oh, wait, my percentage. I just did values. Oh yeah, that's perfectly fine. Yeah, you're saying you put the values. Perfectly fine. The values is 100% fine to use. Values or percents either way. Either one is fine. Doesn't matter to me which one you use because some people want to hear the values, some people want to hear the percents. Either one's okay. And so AJ is saying, I think, how the males right here are more likely to not have a significant other. You can actually see the percentage of males if you hover over it. It was doing it right in that moment. That 60.7% of the males do not have a significant other, compared to for the females 51.55%, and that's the row percentage right here. But overall, you can see it's somewhere between. You can actually find this out. Watch that. 55.65% is the what display. So this is the what display, which you're supposed to talk about for your project. This is the what display for people having a significant other. So this would be the what display for people having a significant other. So we just talked about the conditional displays. So like given someone is female, the probability they have a significant other is 51.55. Given somebody is male, the probability they have a significant other is 60, or do not have a significant other is 60.7. But this is for all individuals. So this is the what display of people having a significant other because it's for everybody in this data set. So we call that the what display because it's on the edges of the table. It's on the margins of the table. So that would be the marginal display. What other questions are there? And this is actually statistically significant, which means what we see here is not likely by random chance. Males are less likely to have a significant other. So what other things should we do? Marginal, great job right there. Excellent. Well, let's throw some points out. What additional questions? Oh, we got to do that chapter. We got to do the Canvas Content 6, right? Do I need to mention? Oh, not for this. Yeah, I know I mentioned it. Great question right there. I'll mention those things a lot of times. It's just because I've done a lot of them, and so I think my brain automatically wants to look at the statistical significance. That's actually the last chapter in the class. That's chapter 19. So you do not have to mention it. Not a bad thing to mention, but like, don't worry, you don't have to mention it. Don't mention it. Let me go over here. Let's hop over here. Let's put a cut in the video. Okay, let's talk about some chapter 6 Canvas content real quick, or Canvas content number 6. Let's go ahead and take a look at it. Luis and Claudia, are looking to recruit people for blood donations. They decide to use a simulation. Are those vampire names? Is this Interview with the Vampire names? Lestat. He's Lestat. No, he is Luis. Yeah, he's Luis and Claudia. And it's Kirsten Dunst who played Claudia. Should I put the mosaic plot and the table? Yep. Make sure to have the table too. Yep. With the graphic. Great question, Layla, right there. You want to make sure you have the mosaic plot and include the table. So make sure your screenshot should look, you could include that. It's nothing in the world. Screenshot should look something like this right here. So that's the way the screenshot should look for that. Make sure to have this table. The table has the values. So that's very important because I can't check your work without the values. So we have here, use the following donations. They've got interviews. How have I not seen this question? Day 1, day 2, day 3, day 4, day 5, and the interviews they have. Use the following table to designate between whether a person is eligible to donate or not donate. Okay, so we got a simulation right here. Based on their simulation, what % of people will not be able to donate? Oh, so we just got to figure out how many of these numbers are 0 through 24 out of the 30 total simulations. So we're doing it as a numeric decimal like this. So 1, 2, 3, 4 out of 30, because there's 30 total. 5 times 6. That's 13.3333. So, I believe so. Let me double check my math. 1, 2, 3, 4, and that's it. I wonder who wrote that. Did Missy write that one? We did this one previously. This is, did not show the rest of that. This one is the one where we're trying to figure out, estimate the probability using the simulation that you get. What is the probability you find exactly 2 of each minifigure? So with this simulation right here, we're seeing if we get exactly 2. So this one obviously is wrong because we get 3 Alexander Hamiltons. With the next, so this one's wrong. This one right here, we're getting a lot of Leonardo DiCaprios, so no. This one right here, we have 2 Alexander Hamiltons, 2 Scooby-Doos, and so that one is correct. And with this right here, so that's one of them. I'm keeping track. This one, let's see if we have how many Leonardo DiCaprios. 2. We have 2 Scooby-Doos and 2 Alexander Hamiltons. Second one that works. We're trying to figure out if we get 2 of each. This one we get 3 Scooby-Doos. So that's wrong. This one right here we get 3 Alexander Hamiltons. That's wrong. This one right here we get 2 Leonardo DiCaprios. We get 2 Scooby-Doos, and then we get 2 Alexander Hamiltons. So that's good. That's 3 out of 7. The purpose of a sample is to have enough data to adequately describe sample. No. The purpose of a sample is to have enough data to accurately describe a population parameter. That's what we're interested in. The blank is a list of collection of things or individuals which the sample is drawn. The sample frame. The sample frame is all individuals or things that we can take observations from. Every 50th person, boom, systematic. Every 50th person is systematic. Where did it say? 10 out of 10, 10 out of 10. That's how we like to do right here. So good work right here. This was maybe the longest time-consuming one. Systematic is every blanked observation. Sample frame is every person or thing we want to understand in the sample frame, is every person or thing we have access to. The population is every person or thing we want to understand. The sample is everything we collect data on, and sample statistic is our estimate of the population parameter, which is what this should have said at the end. The purpose of a sample is to be able to understand a population parameter, which is what we're interested in. So lots of good stuff right here. Oftentimes try to know how this could be a true statement. Like the purpose of a sample is to have enough data to understand a population parameter. We collect sample statistics to understand a population. And the things we have access to sample are the sample frame. So really good stuff. We'll hop over here to space and we'll see if there's any last questions. Let's do this. Great work, everybody, today. Great office hours. Keep working on the assignments. Keep working on the project. We are 8 out of 15 classes done. 8 out of 15 classes. We're 53.333% done. Tomorrow, I think we're 60% done tomorrow. 60% done. Craziness. But keep working. Set aside some time each day to work on the assignments, to come to class. Keep working hard. 3 weeks. Don't miss Stat to 1. Let's get that A. We got some A's on test 1. Let's keep those A's. But with that, are there any last questions as we're about to head off here? You're welcome, Layla. You're welcome so much. I really appreciate it. Look at my Google Calendar right here. Make sure I don't have any meetings. I appreciate all the hard work because I miss seeing everyone in person because it's pretty intense. Like going through working on it, it's like there's a lot of work to be done. But no, I appreciate all the hard work. We got people already ahead working on chapter 13, and that's awesome. So you got this, everyone. If you have questions, email me. I'll be checking out emails. I'll be looking at Discord in a little bit. I'll see everybody later. Bye for now, everyone. Bye.